Welcome all. The previous video introduced artificial intelligence and its role in structural health monitoring. This video takes the next step by exploring machine learning, which enables AI system to identify patterns and learn from data. The concept of supervised learning, unsupervised learning, and reinforced learning are explained using examples from structural engineering application. So first we'll see the basic fundamentals of artificial intelligence and machine learning and what are the different types of machine learning algorithm available and how they are used for different applications in structural engineering. First, what is artificial intelligence? So artificial intelligence is a broader concept where machines are made capable of intelligent behavior similar to human. So this includes understanding data, making decisions, and solving problems. Machine learning is a branch of AI where instead of writing fixed rules, the data will be provided to the system, and from the data, the relationships will be learned and predictions will be made. As an example, we can take for AI as a smart monitoring system which is available to decide whether a bridge is safe or need inspection. So that will be considered as an example of artificial intelligence, whereas machine learning prediction example will be prediction of crack formation or prediction of damage in a structure using past vibration data or past data which are already available. So these are the examples of artificial intelligence and machine learning and how they can be applied for structural engineering application. Next, we'll see about types of machine learning algorithm. So there are three types of machine learning algorithm: supervised learning, unsupervised learning, and third one is reinforcement learning. So supervised learning generally learns from the data with answers that are provided with label. So in case of supervised learning, we'll be providing the data having both input as well as output, from which the new prediction will also be carried out. And unsupervised learning will find hidden patterns in the data which is being provided. And here learning will be done without any answers or without any labels. And whatever the pattern which is available in the data which we have provided will be found out by the unsupervised learning algorithm. And third one is reinforcement learning, where this type of learning is done by interacting with the environment, and the actions will be improved through the rewards or penalties which are being obtained. We'll see example for each algorithm. So for the first one, the prediction of concrete strength or prediction of damage classification as safe or damaged using the past vibration data or past data which is being collected. The prediction can be done with the help of supervised learning. Whereas grouping similar vibration response to detect abnormal structural behavior can be done with the help of unsupervised learning. And reinforcement learning is mainly used as optimization technique, where it can be used for structural design aspect as well. So optimization of traffic signal control on bridges or adaptive structural system which are required during earthquake can be designed with the help of reinforcement learning technique. So we'll see example for each and every algorithm. So first one is supervised learning. So supervised learning, the prediction of load carrying capacity of a bridge or any structural member can be done based on the data which we are providing. So the data will be labeled generally, where we'll be knowing what is the input and what is the output. And based on the data which is being given, machine learning will be carried out and the model will be trained. And finally, we'll be able to predict what is the load carrying capacity of a bridge or load carrying capacity of a particular structural member based on the data which is being given. Whereas if you see in case of unsupervised learning, we'll be able to find hidden patterns. So like if you want to group structural defects which has occurred in the building, we can go for unsupervised learning. And if you want to do any decision making for maintenance strategy, we can go for reinforcement learning, where robot adjusts maintenance strategy for a dam based on performance feedback. So these are the different examples where we are using different algorithm in structural engineering application. So first we'll see about supervised learning. So supervised learning will be learning, the machine learning will be done from the labeled data set, where we'll be knowing input as well as output also. So here we need to provide both input as well as correct output to the model. So the model learns what is the relationship based on the mapping function, and After the model is created, the model will start predicting output for the new data, which is not seen during training process. Next, we'll see what are the key components in supervised learning. So the basic key components which are required are input, output, and the data will be splitted as training and testing data. So the required features which are given as input will be decided based on the target which is required. So in case of finding the compressive strength of the concrete, we need to provide what is the required concrete mix proportions which are being provided to get the required strength. So we need to give input as concrete mix proportion and what are the different ingredients used and what are their proportions. So based on that, we'll be able to know what is the characteristic compressive strength of concrete cube. So similar way, based on the target results which are required, the input features will be decided and the variables will be given as input with the known output. And for the new set of the data, the predictions will be carried out and the model accuracy will be determined. So usually the data which is given for learning will be divided into two sets, that is training data and test data. So training data is mainly used for training the model, where it helps the algorithm to learn pattern from examples with known answers. So after training, testing data is used to check how well the model performs on new data which it has not seen before. So next we'll see the workflow of supervised learning. So here I've taken an example of predicting the compressive strength for new concrete mix design. And here if you see, the first step will be the data collection. So for supervised learning, we need to have the first step as data collection, where the data will be collected. And here the required data are cement percentage, water cement ratio, aggregate type, curing days, etc., and any other concrete ingredients which are used. And output required is measured compressive strength of concrete. So based on the lab tested data which has been collected before, the input will be given and model will be trained. So for training the model, we need to choose algorithm. So we can either go for linear regression or random forest or any other type of supervised learning algorithm. So depending on algorithm chosen, accordingly the output will vary. So usually whatever the data which has been collected, in that only around 70 to 80% of data will be given as input with the known output to model with labels, and this will be required for the learning process. And after that, the testing will be carried out, where 20 to 30% of data which is not seen by the model will be used for the prediction. And finally, the predicted compressive strength will be compared with the actual compressive strength to see the accuracy of the model developed. And this model will be used to determine the compressive strength for new mix design. So once the model is trained and finally it is deployed, we'll be able to know what is the concrete compressive strength. Prediction is done by using supervised learning algorithm. So the steps involves, first step is data collection, where the data which is required to predict the concrete compressive strength will be collected. That can be even lab data and test data. So all these data will be combined together and the required input and output will be given. Then next will be model training and testing. So for model training, we'll be using 70 to 80% of data, whereas for testing, we'll be using 20 to 30% of data. And based on the accuracy of the model, we'll be able to decide whether the model is able to predict the compressive strength with a higher accuracy or not, will be determined. And after model training and testing, it will be deployed and the model will be used to estimate the compressive strength for new mix design. So next we'll see what are the different learning algorithms which are available under supervised learning. So under supervised learning, we can go for linear regression, decision trees, random forest, SVM, or k nearest neighbors, or ANN. So depending on application, what we are choosing, and depending on our requirement, we can go for different algorithms. So different algorithms are selected depending on whether the task involves prediction, classification, or handling any complex data pattern. Accordingly, we can choose the algorithm. So first one is linear regression. So linear regression is mainly used to predict continuous numerical values such as estimating the load carrying capacity or compressive strength of a structure. Next algorithm is decision trees, where decision tree makes prediction by using simple yes or no decision rule, making the process easy to understand and interpret. And then random forest. So random forest is nothing but combining the multiple decision trees to improve prediction accuracy and reduce the error. In support vector machine, it is mainly used for classification tasks, such as whether the structure is damaged or undamaged. So that can be done easily with the help of support vector machine. And k-nearest neighbor, it is mainly used to predict the results by comparing new cases with similar past cases or nearest data point. And ANN, it is a separate broad topic, that is artificial neural network. It is used to model complex non-linear relationship, and it is widely used for prediction and classification problems in structural engineering concepts. So these are about algorithms which are used in supervised learning. So next we'll see what are the applications where we can use supervised learning algorithm. So these are the different applications, like example, predicting structural load carrying capacity, crack with estimation from the sensor data, classifying the bridge components as safe, repair needed or critical, then predicting the damage level during seismic event based on the building parameters, then monitoring the deterioration trends in pavements or any existing structures. So these examples show how machine learning supports prediction, classification and condition monitoring in structural engineering. So depending on the requirement and application, we can go for choosing particular algorithm based on the algorithm which has been classified under supervised learning. So next we'll see about unsupervised learning. So unsupervised learning, in this type of learning, the model learns patterns from unlabeled data, that is no predefined correct answers. So it will find the hidden structures, groupings or patterns in the data. Its main purpose is to find hidden patterns or similarities or groups in the data automatically. For example, students can be grouped by observing similarities between them even without knowing their marks. Next, we'll see what are the key components. So in unsupervised learning, the model works with unlabeled data. So in order to understand and analyze this type of data, it mainly uses key functions such as clustering, dimensionality reduction, and pattern discovery. So clustering means grouping similar data points together based on their characteristics. Example, grouping buildings with similar damage conditions. Dimensionality reduction means simplifying larger amounts of data while keeping the most important information. It is mainly used to reduce the complexity and makes the analysis easier. Pattern discovery, it is mainly used to identify the hidden trends or relationship which is present in the data. For example, finding how environmental conditions influence structural deterioration. So that can be determined from the pattern discovery. So next we'll see you the workflow or steps involved in unsupervised learning, and example taken here is grouping the bridging components by their health condition, like healthy or they are suffering from minor defects or severe defects. So the step one remains same as supervised learning, which involves data collection. And here, in order to group the bridge components, health condition, we need to know sensor readings and vibration frequency, strain level, displacement. So the data related to these all will be collected, and based on the data collection, the model will be trained. And here the data will be fed without any good or bad labels. So step 3 will be pattern formation, where the algorithm groups components into clusters, like example like healthy, or it has minor defects or severe defects. And finally, based on the clustering of the data, we'll be able to see what is the maintenance activity or priority that has to be done in order to safeguard the bridge from the future failure. So workflow involves data collection, and after data collection, model training and pattern formation will be carried out, and from that the decision making will be done. And unsupervised learning algorithms which are available are k-mean clustering. So k-mean clustering is used to group similar structural data into k groups. In structural engineering, we often use large data from sensors which are collected, and the data involves measurement of strain, acceleration or displacement reading. And this method groups similar structural response pattern and will be able to identify different behavior zones in a structure. And here we need to define the number of clusters required. So, okay, for example, if you are dividing it as a minor defect, major defect or severe defect, we need to give the number of clusters as 3. So here we need to define how many numbers of clusters are required. And example, we can see that the bridge vibration data, it's classified as normal traffic load or heavy traffic load and abnormal load condition. So here also same, the number of clusters that we have to give as an input will be 3. And next one is hierarchical clustering. So this hierarchical clustering is mainly used to create a tree-like structure of your data groups based on similarity. So if you see in structural engineering, it helps in understanding how different parts of a structure behaves similarly or differently. So here we need not fix the number of groups as in the case of K-mean clustering. Damage assessment in buildings can occur in different floors or beams. Whatever the patterns which look similar will be captured here. So the similar crack patterns which has observed in different floors or beams will be grouped together to understand the damage progression. So that is a highlight of hierarchical clustering. And third one is density based clustering, which is called as DBS-CAM. So this is mainly done to group based on density, and it is mainly useful for identifying the noise or outliers which are there in the data. As discussed before, the structural health monitoring data will be of larger amount and will be having huge data. So if you are having any anomalies in that data, or if there is any noise in that data, that noise can be easily detected with the help of this type of algorithm, that is DBS-CAM. So in structural engineering, it is mainly used to detect anomalies in structural health monitoring data. And it also separates the normal structural behavior from abnormal or damaged condition. So it can even detect irregular shapes and can also identify outliers which are often represent whether it is damage or not. Next one is PCA, that is principal component analysis, and here it is mainly a dimensionality reduction technique and not a clustering method, and it is used for reducing the complexity of the data which is being given for the machine learning. So we collect large amount of sensor data from buildings or bridges or dams. So this type of PCA algorithm is mainly used to reduce the high dimensional data to the few important features, where the analysis can be done at a faster rate and in the easier way. In structural health monitoring, PCA can reduce hundreds of vibration signals to a few principal components that represent overall structural condition. So thus clustering method helps us group different structural pattern behavior, while PCA helps simplify complex structural data for efficient monitoring and damage reduction. This is about the example of grouping which components by condition. You can see that the data given based on the crack density and the crack width, the clustering has been carried out as healthy and it needs monitoring, and this is in critical condition. And if you see, the clustering has been done. So this figure shows how unsupervised learning can be used to group bridge components based on their condition using K-mean clustering. And here the number of K or clusters given as 3, which is healthy, needs monitoring and critical. So x-axis represents crack width in millimeters. Based on similarities in the data, algorithm has automatically formed the different groups without any predefined levels. So blue cluster, that is healthy, components with smaller crack widths are grouped as healthy, whereas next cluster which needs monitoring or moderate crack width, which are having moderate crack width, are grouped as needing monitoring required. And third one is critical components with larger crack widths and density is also higher, and this is considered as a critical cluster. And if you see, there is a X symbol which is indicated at the center of cluster. So this indicates the cluster centers or centroids identified by the K-mean algorithm. So this example shows how unsupervised learning can automatically organize structural condition data and support for condition assessment and maintenance plans. So different applications of unsupervised learning or grouping structural elements based on damage patterns, and if there is any unusual sensor readings which can be noise in the sensor reading, that can be easily detected. and if there is any change in the pattern of data will also be identified easily with the help of unsupervised learning, and hidden correlations can also be determined in the material test results, and grouping similar failure modes in the structural system can be done with the help of unsupervised learning application. So next we'll see reinforcement learning. So reinforcement learning is a type of machine learning where an agent learns by interacting with its environment. So here it does not learn from any fixed data, instead it learns through trial and error. So if there is any correct action, the rewards will be received, and if there is any wrong action, penalties will be received. So over time, the agent learns a sequence of decisions that gives the maximum reward. See the reinforcement learning steps, how it works. It basically starts from trial and error, and it gets a feedback from the environment. Based on the feedback, it will try to learn from the experience. And here there is no fixed instructions, like no step-by-step rule. The skill improves by interacting with the environment and adjusting the behavior based on feedback. So we'll see what is the workflow and example for reinforcement learning in structural engineering. Optimization of structural maintenance scheduling can be done with the help of reinforcement learning. And here we need to define the environment after the data collection. So the environment can be bridges, roads, or building components which are requiring inspection, where we are going to plan the schedule, maintenance schedule. Step 2 will be agent action. So decide which structure to inspect or repair next. Step 3 will be rewards. So it can be either positive reward or negative reward. So negative reward will be unexpected breakdown due to delayed maintenance, whereas positive reward will be preventing the failure yearly. And step 4 will be learning. So model improves decision making after each cycle based on the rewards here. So this shows how the reinforcement learning can be applied to optimize structural maintenance schedule in civil infrastructure. And mainly, if you see, reinforcement learning helps optimize maintenance decision by continuously learning from structural performance and failure risk. It is important to note that reinforcement learning does not require actual bridges or buildings to fail repeatedly. In most structural engineering application, learning process takes place using historical maintenance data or computer simulations of structural deterioration. So the agent learns to minimize future failure risk based on those data, and maintenance cost will be determined based before any severe damage occurs. So reinforcement learning algorithms which are available for intelligent decision makings are Q-learning, deep Q network, policy gradient methods, and SAR-SA. We'll see one by one. Q-learning is a basic reinforcement learning method that learns the best action for each state. And in structural engineering, a state can represent the condition of a structure, such as healthy, minor damage, or severe damage. The action can be inspection, repair, or reinforcement. Algorithm learns which action gives the best long-term outcome for each structural condition. Second one is deep Q network. This is a deep learning algorithm where it is used for complex problem. It is an advanced version of Q learning, and it is useful when the system is very complex or when we are having large amount of sensor data from structures like bridges or smart buildings. So it is mainly used to analyze vibration, strain, and displacement data to make smarter maintenance decision. Third one is policy gradient method. So this type of method directly learn the best decision making strategy called a policy. So instead of focusing on individual action, it learns what is the best overall strategy for decision making. In structural system, it can help design optimal maintenance policies for long-term safety and cost efficiency. And last one is SAR-SA, that is S stands for state, A stands for action, R stands for reward, S stands for state, and again action. So it starts from state, action, reward, then again state and action. So it's a reinforcement learning method that learns based on the actual next action taken. So this makes it more realistic because it considers the real behavior of the system during learning. In structural engineering, SAR-SA can be used in adaptive systems that continuously update decisions based on real-time structural responses. So applications of reinforcement learning involves automatic inspection schedule for large infrastructure network, adaptive traffic signal control to reduce the congestion near the construction sites, then optimizing the reduced resource allocation for post-disaster repair, real-time decision making in structural control systems. So to summarize, so this video introduced the three major types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. Their working principles and structural engineering applications were also discussed. So these techniques form the foundation of modern AI systems used in prediction, monitoring, and decision making. So the discussion will move on to the neural network and deep learning in the next video, which enable AI system to learn complex patterns from engineering data. So the key takeaway from this video involves machine learning enable data-driven prediction and pattern recognition can be done, and decision making can also be done for the structural engineering application. Thank you for watching and see you in the next video.